Greetings, everyone, and welcome to the ASME DSCD podcast interview series. My name is Selena Pan, and I will be your host for this episode. And our guest is Dr. Katherine Strausser, or Katie, who currently works at Exobionics. She did her PhD at the University of California, Berkeley in controls and robotics, and has been working her way up through her startup and now is a principal engineer. I have that right. You can correct me if I don't. And we are very excited to have her here on our episode today. Welcome, Katie.
Thanks, Lena.
So I thought that we would start a little bit about your research and personal career trajectory. Tell me about the latest project that you're working on and manage.
So Exobionics focuses on making robots and specifically exoskeletons that help provide support and assistance to people. I focus on the medical side. So the robots that I work on are helping those who have had either a stroke or spinal cord injury or otherwise have been injured in a way that affects their gait to be able to regain some strength or control or get some exercise while wearing the device as part of their physical therapy regimen. My latest project is working on the next generation of these devices. As we've rolled them out into the field and we have more and more people using them in the clinical setting, we have seen more of the user's needs and are trying to adapt the robot to be more specific to what's needed in the clinical setting. So we're expanding the number of patients that we can work with and help, and then also making the device just easier and more reliable for the therapists to use it.
Very cool. And just very much a contribution to society.
Yeah, I think that's one of the best parts of working at EXO is that our work is directly helping individuals who are recovering from a really traumatic injury or illness, and so being able to help them recover faster and better is really incredibly rewarding.
Yeah, that's awesome. I'm really glad that you have ended up so far here working on EXO, but let me go back in time a little bit and ask you, how did you decide you wanted to go into your field, controls and robotics, and then this particular application?
I think I had a bit more of a stumble into it rather than a choice to go into it. I have always been interested in robots and robotics and knew that I wanted to work in robotics, and I thought I wanted to work in rovers and other wheeled things when I entered graduate school. And just by where there was lab funding available, I ended up in this exoskeleton lab, not working in wheels, working in legs, which might be the opposite. But I fell in love with it pretty immediately. So it wasn't something that I was very clear on that I was going into, but the opportunity arose, and it's been amazing ever since. So I haven't looked back to go back to rovers, but I decided on controls in a similar way. I wanted to work on robotics, so I'm pretty sure I put robotics on my application and they assigned me into controls.
Nice.
But again, I really enjoy the subject matter and got to know, more taking classes early in grad school, and I'm really glad that that's where I ended up.
Yeah, it sounds like for both of those, that's a good lesson and example of how you don't have to have everything sorted out by junior year of high school or something like that, and you can have a very successful and rewarding journey just by going with what you're interested in.
Yeah, I think taking advantage of opportunities as they come. If something sounds interesting but maybe wasn't on your plan, it's okay to divert from your plan and try something out that sounds cool.
Yeah, engineers really like plans, so
yes. yeah.
And I guess another question I have, because most of our guests so far have been in academia, you're our first industry guest. How did you decide you wanted to go into industry and also a startup in industry?
Again, less of a decision, more of it happened. I actually entered graduate school intending to go back to industry. I entered as a master's student and did not intend to stay for my PhD. Fell in love with the work I was doing and decided to stay for the PhD. Along the way, I did look into staying in academia. I really do enjoy teaching and I love sharing what I know. But ultimately, the opportunities that I had been given through the exoskeleton world were just too good to pass up and to leave that. And so I decided to stay working on exos. Exobionics, the company I work for now, was actually founded by Professor Katherine at UC Berkeley, who was my graduate student advisor. And so I had the opportunity to basically continue working on my graduate work. And I've been working on that for now more than a decade. And so that took me to the startup realm. I'm not sure I would have chosen that if I was just coming out of school without that available to me right then, but it's been a really interesting journey and I've really loved it. So
I really like your story also because it seems like you always hear these horror stories of people who start out wanting to do a PhD and then they decide that they want to leave the master's, and to everybody in the PhD program, that seems terrifying, but really it's everyone's own path, and yours happened to take you in the opposite direction.
yeah, I had a lot of decisions to make when it was time to choose between leaving with a master's or staying with a PhD. And I think because I had come into it with the intention to leave, it was a bit of a different spot than those of, in our class who were deciding whether or not to leave. That felt like a bailing out. And I was just had two paths, and that was really advantageous. And ultimately decided that if I left, it would be a lot harder to go back into school. But if I stayed, then if I decided it really wasn't right, I would have gotten some good experience and could leave later. So,
yeah. So even though you didn't have the strictest plan like most engineers like to have, you did still go with a conservative fallback plan.
It was a very conservative fallback plan, yes.
Nice. So we can't get the engineer out of you.
Risk aversion, always, yeah.
Cool. So I guess I want to know a little bit more about your area and industry, and especially in terms of challenges. So as we all know, across tech, across engineering, there are a lot of challenges to adoption of new tech. Examples being the application itself, the infrastructure around it, for example, equitable distribution, legal regulations, and so on. What do you see as the biggest challenge for your work?
That is a fantastic question. And I think something that I was completely unaware of leaving academia and going into industry was how much of an impact regulatory and financial and things and other things had on adoption. So working in medical devices, obviously the hardest thing is getting approval. So you have to build a device and show that it is safe and effective for use before you can really get it out in the market. And depending upon the class of your device, that can take different paths, but it takes a lot of time and a lot of money. And so that can be a really big point of failure for many companies. Just getting through that time period is really, really difficult. We were
time of that? Like, what is the time span of that? Is it months, years?
It depends upon the class of the device and how long it takes to do your clinical trials and how much you are able to kind of optimize how you run those trials and things like that. So in an exoskeleton right now, you have to show safety data. You don't have to actually show pure efficacy outcomes. So we don't have to do follow-up studies and things like that you might have in other products. So it shortens the timeline a little bit, but you're still looking at finding patients, enrolling them, and working through that. And it depends upon what diagnoses you go for as well, because you have to be able to recruit those patients. So it becomes very difficult to get clearance for diagnoses that are harder to find sufficient number of patients for, and things like that, which goes back to your point about equity and distribution. It can be really difficult to make that happen. Even once you have FDA approval, then the question really becomes adoption. And so you're asking doctors or therapists or hospitals to change their standard of care and to adopt a new device. And no matter how much you believe in it, you basically have to sell it to every individual who's going to use it. And that goes all the way up the chain, from the physical therapist who will operate the device, to the doctors who might prescribe it, to the hospital executives who actually have to put forth the money, to even sometimes philanthropists who are the ones who make the donations to help buy the device. Eventually, you hope that insurance will cover some of the cost of acquisition of that device, but that's a really long path. And right now, that's not covered for exoskeletons. The treatment with them is, but not the actual hardware. And so those things are really big challenges to the industry. And we've seen really great results. There's a number of exoskeleton companies, but it's still not what I would consider standard of care because of a lot of the adoption hurdles.
Right. It's really interesting because a lot of people think of academia's product as papers, and when compared to certain industry fields, the paper turnaround time of several months seems very slow. But then depending on what field and industry you're in, like biotech, that can be even slower and sort of frustrating, although it is a product that people will actually use and physically in their lives.
Yeah, but there's still a lot to go into before that product gets out to them. So
I mean, in a way, it's very reassuring to me, somebody who will need medical care for various things in the future as I age, and knowing that while you're working on this, that the horizon is so far off, it could be discouraging for the people who are working on it. But for potential customers, it must feel reassuring to know.
I think being involved in the FDA process has made me definitely appreciative of it, because I kind of go into, a medical situation where I need care, or know that in the future when I need other care, that what I'm going to be using is safe. I understand the process that it went through, but it can be really painful to go through it at the same time. So yeah, I agree.
No, it's fear can almost always be assuaged with knowledge and understanding of what is scaring you. So yeah, thanks for that deep dive into the process. I'm going to switch gears again.
Sounds good.
So let's go back to our student days. So say you have a student getting an undergrad degree in engineering whose goal is to land a job in robotics. Do you have any advice for them? Anything from the types of courses to take, electives, activities, clubs, things like that?
Definitely. I'm actually in the midst of reading intern resumes right now to hire for next summer. So what I'm looking for is obviously top of mind right now. So this question really speaks to me right now.
She's recruiting everyone.
Yeah. The biggest thing I would say to students is to get your hands dirty, to get out there and do projects, preferably in the industry that you're interested in. Now, obviously, if you look at my path and the things I might have done in undergrad, were definitely not exoskeleton based. I didn't know what an exoskeleton was at that point, but I was able to get experience in some projects that at least exposed me to things and allowed me to determine if that was the direction I wanted to go or not. When I'm looking at intern resumes, seeing a really high GPA is fantastic, but when I bring a new engineer or an intern engineer into the company, I'm going to expect them to be able to build something that will work. And so being able to show that you've taken those skills that you learned in the classroom and applied them to a project is really important. And that could be a course project, or it could be a club, or it could be your own project that you post on Instructables or something like that. Anything that kind of shows me that you can take that book learning and apply it to a project. I also think that clubs like, Formula SAE or Society of Women Engineers or any of those things are really good networking as well as project building. So I would highly encourage you to check any of those out if they're on your campus.
Yeah, that's great advice. I wish I had done more hands-on work when I was a student. Because even when you learn something in the textbook and then you go and try to write it in MATLAB and homework, even that sometimes is just very different than what you expected.
Yeah, and I think taking book problems where you assume that all of the information is there and that there is a solution, and then going to the real world where like you're going to have to make some assumptions, or maybe information is missing and you either have to find it or figure out how to cope without it. And it's much different. So I think that those skills are so, so important.
Mm-hmm. Yeah, definitely. And that also kind of speaks to that cliche that everyone says, engineering trains you how to think in a way.
Yeah. And I would also say, don't be afraid of, picking the wrong club. To my earlier, answers, it's like, you can change your path, but if you are applying to a biotech job and everything that you've done is in, cars or something like that, it is helpful to explain in your resume that your switch is intentional and that you're looking to get, into a different field. So,
yeah, that's also really good advice. Once again, I feel like a lot of students are trained to think that their resume needs to tell the most coherent story ever, and they're not allowed to have gaps or switches, but you are, and you're allowed to be a human being and change your mind and be able to explain to recruiters why you changed your mind. That happens.
Yeah, and I think the most important thing is to show me that you are changing your mind and you're not just sending out resumes to every job posting in the world and hoping that someone hires you, that you are intentionally applying for that position is really important to see.
Yeah. Awesome. Yeah. Thanks.
Mm-hmm.
Yeah, so I guess another topic that is very relevant to both universities and companies at this point is that corporations and schools are realizing more than ever the importance of DEI and an inclusive environment. And I know that you are very passionate about this. What are some of the types of actions and initiatives that you found to be most effective?
It's a really good question. I definitely find that can be a struggle, especially in a small company where, it's hard to hire to, meet quotas or anything like that, even with the best of intentions, because, the teams are small and you have very few people and very specialized needs. But I think one of the biggest things that I've seen is that representation really does matter. So I think having people of color, having women, having, a wide variety of people in your office makes it a lot easier to recruit other diverse people, because it already kind of sets up this atmosphere of inclusion and diversity. Obviously, you have to start somewhere, and that can be really difficult. But I do think that once, you have people making sure that, a diverse group of people is represented on committees and stuff, even if it's the party planning committee, making sure that you have, diverse representation is really important.
Yeah. Being able to walk into a lab or a company and see more than one type of person is huge, because often it's not the case.
Yeah, I think that's so important. And I mean, we build devices for people with spinal cord injuries and who have had strokes and things like that. And so we have also employed people who use assistive technology in various ways. And I think that that's really important because their experience and perspective is so incredibly important to us building, the product that we make. But also when people come in and test and things like that, they see that our company is not just making stuff for those, for other people. It's really about our community and that they are part of that.
Right. I think everyone should hear about EXO because it becomes so obvious when you describe, okay, yes, our product is for people who need assistive technologies. So it's very reassuring to the customer when they see that the people designing and manufacturing the product are a diverse group of people, so they can be sure that they're represented and their specific needs are covered. But that's not so obvious when it comes to every product out there, even though it should be. So I think this is really good example. It's really clear.
I think we're also pretty unique in that our products fit on the human body. They actually have to fit and contour to the body. So making sure that body types are represented is actually really important as well. Whether that's a diversity of height or weight or even just body shape. So making sure that, straps and belts fit men as well as women. And then, straps fit people who have been paralyzed for years, as well as people who do squats all the time. That, physical diversity is so important to our work. And if you don't have a diverse workforce and don't think about finding that, then you're going to miss the mark for a lot of people.
Exactly. Like, this is once again like such a clear example that you just wonder why it's not applicable to more spaces, for example, the fashion industry.
Yeah, I definitely, having built straps and, harnesses and stuff for a number of body types, it's amazing that more people haven't, kind of embraced that, because you really need to have everyone represented.
Yeah. So anyway, speaking of being part of the human race and spending your time doing other things besides working, what books, news sources, podcasts, websites, etc., do you personally enjoy regarding engineering, robotics, or anything else that can be consumed and enjoyed by lay people?
So I have to admit, I am not much of a technical podcast or website listener. I, kind of for fun, I'll go and do my research and stuff like that. But my podcasts tend to be very not related to work, as kind of a mental break. However, I do love listening to like Science Friday and stuff like that on NPR, and just kind of catching those news clips. Just because sometimes something kind of catches my ear of, oh, that's a really interesting field, and I can go look into it more later. Mm-hmm. An example is, I was listening the other day, there was a story about treating depression with transdermal stimulation. So they're basically electrocuting the brain, and we use some similar techniques in the robotics field, especially with tremors and things like that. And so there were some parallels, but I think when you listen to like the news or NPR or something like that, it's just so accessible, and you get that information kind of in bite-sized chunks, and it doesn't feel like a chore. It just feels like that cool fact that you learned this week. So that's how I like to approach my science learning.
Yeah, that's great. I mean, I think we all deal with that challenge sometimes of when does work bleed into our personal life and vice versa. Mm-hmm. And that can be hard when your field is so technical yet so closely tied to cool news reports. Then sometimes you're too exhausted to
yeah, I mean, I definitely like reading news stories about, kind of the feel-good stories about devices and rehab strategies being used that kind of come up in the evening news from time to time. Mm-hmm. Just because it helps kind of humanize what the work we do. Yeah. But I also like hearing, the latest on self-driving cars or the next, NASA mission or whatever.
James Webb, what?
James Webb Telescope, yeah. And I mean, following NASA on Twitter and stuff like that kind of gives me those bite-sized pieces that doesn't feel overwhelming and technical, but kind of continues to keep my interest in what's going on.
Yeah, it sounds like it's a good balance.
Yeah.
So I have one last question for you. And it's one that I've used on this podcast before, but I really like it. So I once read a letter to my 26-year-old self by Joan Juliet Buck that said, find things that are good for you that are not work, romance, social life, or shopping. Since many students and young people who are starting out in their careers are in this age range, what have you found for yourself that are good for you that are not work, romance, social life, or shopping?
So for me, the answer to this is undoubtedly music. I've been a musician for all of my life, and music has always been my escape. Music is relaxing, but still challenging, but in a very different way than, the latest engineering problem or whatever. And it gets you away from your screens, although now my music is all on my iPad, so I guess that's failed, but it kind of gets you away from, that day-to-day work, and you have to focus, but it's on, something relaxing. And so all through college, I played in band. In grad school, I played in a brass band with some other grad students, and I currently play in a band as well. And that break has always been really, really important to me. And so, yeah, I'm not saying music is for everyone, but if you're a musician, keep playing. So.
Yeah, if you know, you know.
Yeah.
Yeah, that is honestly, it's a hobby, and it's also a mental break and a mental exercise, it seems, all in one, and also a passion. So it kind of sounds like you found everything in it.
Well, it's also frequently a large part of my social life too. So I've always played in bands. Well, not always, but since college, in high school, I've played in bands. And so I formed friendship circles around that as well. And it's a lot of people who I wouldn't have met in just, the engineering work realm, or, a wide variety of ages and backgrounds and things like that. And so it's been a really great way to kind of continue to get input from a very diverse group of people, and to meet other people who I might not have, and to just have some fun and relax. So.
Yeah, no, I totally agree. If you're okay with me revealing the fact that we're both in our 30s, I think that's a lesson that a lot of us are learning in our 30s, is that it's so important to have friends and relationships outside of your professional circle. And especially in controls in graduate school, that's really hard to do. So once you get out there into the world, like finding things and people who aren't related directly to your career is so important and so helpful to your well-being.
Yeah, I agree. When I go to band practice, no one asks me if my controller was stable. No one has asked me about the latest dynamic model.
Amazing.
It's just such a nice break. But, people who have diverse interests and, challenge me to think differently and to, work hard on something else that's a break from work has been really, really valuable.
Yeah. That's great. Cool. Well, I think we're at the end of our time, and I'm so glad you were able to take the time and space to talk with me today. It's been really great having you on here.
Thanks. It's been really fun to talk to you.
And that concludes our episode. Thanks for listening, everyone.